Good morning, everyone. Nice to have everyone here. Actually, I should rephrase. We're having this live around the world. Good morning, good evening, General ZM, GM. I'm Hudson, VP of Community at Polygon Labs. Also voted handsomest L2 Rascal by Time Magazine this year. Very big honor. Didn't even know Time Magazine cared about layer 2 technologies. So we're having today the Aggregation Day, and we are also going to be talking to people internal to Polygon Labs. We're going to be talking to people who have built this, talking to people external to this about a lot of cool stuff. We are very, very excited about today. So we're going to go ahead and get started. I'm going to see if the screen share works. And it does, the magic of live streaming. So yeah, what we're going to do is go ahead and invite people on stage here. Let's see if they made it in.
You send people over, right?
Yeah.
There we go. All right, Brendan up here first. Hello. Brendan Farmer is a co-founder of Polygon and a works on Polygon Zero. So Brendan, go ahead and take it away.
Oh, great. Thanks, Hudson. Can we get slides up? Are there slides or? Hey, Jordy.
Oh.
Hey. Okay, so slides. I'm actually not able to see the slides, but all right. So hey everyone, I'm Brendan. I'm from the Polygon ZK team, and I just wanted to talk a little bit about the blockchain. So a couple weeks ago, we published this post, and in it, we made two claims. So the first is that no single blockchain is capable of supporting the throughput required for an internet scale crypto ecosystem. So this is sort of a challenge to the monolithic view of scaling. The second claim is that even if we add block space and scale horizontally, if we do that while fragmenting liquidity and state and users, then we failed in some sense. So like when we talk about scaling in crypto, we really mean scaling access to liquidity and to shared state. And so this forms the basis for the aggregated blockchain thesis, which is we need a horizontally scalable multi-chain ecosystem, but we need to be able to have that while preserving unified liquidity and shared state and composability. So the sort of the upshot of this is that Polygon has released this vision for the aggregation layer, which we view as like this foundational piece that will allow us to provide this. So a multi-chain ecosystem that still has unified liquidity and state and composability. And so next slide. I can't see the slide, so I hope that it's the next slide. But and so when we talk about unified liquidity, in my mind and in Polygon's mind, that has two components. So the first is asset fungibility. Like if I'm in the Polygon ecosystem or this multi-chain ecosystem around the aggregation layer, I should be able to take ETH on ZKVM, and I should be able to bridge it to like the OKX chain or like A-Star or Manta or Canto, and I should get ETH on that chain. I shouldn't get wrapped ETH. I shouldn't have to rely on liquidity providers to swap me back into the native token for that chain. And so the second component, the second requirement is fast cross-chain transactions. So right now, if you think about how rollups and cross-chain rollup transactions work on Ethereum, I need to, in order to send a message from rollup A to rollup B, I need to first submit my transaction to rollup A, generate a proof, wait for that proof to be submitted to Ethereum, wait for that block to be finalized on Ethereum, and then finally rollup B can accept my cross-chain message. And so this doesn't work for unifying liquidity and shared state. And so the aggregation layer, and next slide, is proposed as a solution for this. So right now we have this fragmented L2 ecosystem, and if we continue along this path, then even with 1 million rollups, even with like as much block space as we could possibly use in the world, we still will run into this issue where we have liquidity and state that's fragmented across all of these rollups. We need a way to unify that environment and make it feel like using a single chain for users and developers. So fundamentally, the aggregation layer is a decentralized service that sits sort of beneath the L2 chains in the Polygon ecosystem. So it allows for safety for asset fungibility and super fast cross-chain transactions. And it allows for all L2 and L1 native assets to be deposited in a single unified bridge so that I can have like L1 native ETH on ZKVM, and I can move it to ZKPOS or to the OKX chain, and I can get back L1 native ETH on that chain. Similarly, for any L2 native asset, I can take that asset and I can move it between chains really, really fast. And fundamentally, I can do so in a safe way that doesn't jeopardize the assets that are deposited in the bridge. And I can do so without requiring an L1 interaction. And so for us, like the aggregation layer is kind of this foundation that provides safety. And then we envision sort of an emergent ecosystem of coordination mechanisms like shared sequencers, like relays, like builders that allow for this cross-chain interaction to happen. But fundamentally, they can do so in a safe way. Users and chains don't have to trust these actors to not misbehave. They don't have to trust the aggregation layer. And so they can transact in like a super low latency way without additional trust assumptions. And so next slide, please. So today, the sort of upshot of all of this is that the first component of the aggregation layer, which is the unified bridge, is live today on mainnet. The LXOY bridge contracts have been deployed, and this is sort of the basis for additional CDK chains to plug into this emerging ecosystem. The second milestone is going to be proof aggregation, and I am really glad to have Jordi here to talk in detail about proof aggregation.
Yes, thank you, Brendan. Yeah, in the core of this aggregation layer is this proof aggregation. I mean, proof aggregation is very much exploring the recursive snarks technology. Recursive snarks has been theoretically set for a while, but practically has not been. So the space has not been putting this technology in practice until the ZKVM launched. Actually, in the ZKVM, we are using a lot of these aggregations. When we are taking many batches and we are aggregating together to a single proof that prove a segment of a blockchain that includes different batches. So mainly what we are doing is we are taking a batch of a proof, another batch of another proof, another batch of another proof, and we are aggregating them together. Okay, so next slide. What we do in the aggregation mainly is using this technology of aggregating proof to aggregate many proofs of many chains. You can go to the next slide, please. Yeah, so here is we are taking a proof of a chain, another proof of a chain, and we are aggregating them together to a single proof. But we do that recursively. We take another proof and we aggregate them together. And then we take two sets of proofs and we aggregate them together. So at the end, maybe once per 5 minutes, we are taking all the proofs of all the states of all the chains. We are computing a single proof that proves all the chains, and this is the chain that we are setting that on mainnet. And because it's a ZK proof, we have the warranty that the state transitions happens in the right way, that the security of the full ecosystem preserves, and that everything works. But here the important point here is this proof, this ZK recursion, this proof aggregation that we are using and extensively inside Polygon. Why is important this in the aggregation layer? Because you cannot, here all the point is that you cannot start using the funds in another chain until you are sure that those chains has been exited, that has been happens in the first chain. And the proof is the generating this proof is what rules it all. Okay, this compared, for example, with optimistic approaches, you don't need to wait for gamings on that. You just have the proof. You know that this is correct. You can go right. So here is the main topic. And yeah, that's very much what I wanted to explain about the proof aggregation.
Awesome. Mark, I interrupted and stepped on your intro talk because you were not on stage. Do you want to give it now?
Yeah, no, I think maybe setting the stage for some of this would be really good, right? When we really think about, well, first I just want to say, like, I think today's going to be a day that we are going to have some of the best ZK content that you can possibly get. And that's not just coming from our internal teams, but really awesome external speakers as well, which is really exciting. But what you just saw, right, is like the core of everything that we do is really ZK tech at Polygon. And when we were evaluating like paths forward from like a scaling perspective, what we realized is that ZK tech is going to be at the core of that. And when you take that one step further, what you realize is that there is a way to improve on kind of blockchain approaches that have been taken so far, right? And so like the two popular approaches, right, is like monolithic blockchains and modular blockchains. And we started thinking about that. We're like, okay, monolithic chains have problems that everyone recognizes. Modular blockchains have been viewed as like an improvement on that. But the downside of them is this fragmentation that you get. And so what can we do to bring them together, right? And I think we're uniquely positioned with the ZK expertise that we have to bring them together into aggregated blockchains. And you've heard a lot about like Polygon CDK if you've kind of followed Polygon at all. But what you've heard a lot less about is kind of the stuff that we're jumping in today. Brendan gave a good intro on kind of that first part of the AggLayer going live. And that's a very core kind of first component of it. But there's going to be multiple stages to this. And Jordi talked about a very important kind of second stage of that, which really has to do with proof aggregation. And we're going to need to go even further than that to get to that low latency AggLayer that we all want, and that is going to create that amazing user experience that people have probably heard us talking about. And so I'm kind of excited for us to just continue to explore that. I think kind of setting the stage with what the AggLayer is and what that next stage would look like with proof aggregation is kind of like a really good start. And I think maybe we could jump in now to talking about what some of those kind of benefits to the AggLayer are going to be. Brendan, if you want to kind of take that away. Moderating it, I think that'd be a good place to head now.
Yeah, sure. Happy to, Mark. So I guess the first question, I'll direct this to Sandeep and Mihailo. What is sort of the end game vision? Like when you imagine this like internet scale crypto ecosystem with a ton of chains and like something that looks different from what we have today, like what do you see?
Yeah. Maybe I can start, and Mihailo, then you can take up. So I mean, for me, it goes back to the roots of when we started. And I have multiple times stated also that given a choice between like two architectures, which kind of takes us to a path where there will be some midterm great scalability, but then it is not the long-term solution versus a solution which is in the long run is going to be, it is the solution which can be the next this trustless internet or Web3 that we call. We'll always choose that. And aggregation layer is, or the aggregation mechanism, and with this Polygon AggLayer, I think like all of us, first time we believe that this is one architecture which can actually scale blockchain networks to the scale of the internet without compromising the security of the system. And then there have been multiple kind of definitions of aggregation that has been given. To me, I feel that it's very simple, that all of these chains, these are all individual state machines, and then aggregation is basically aggregates all of those state machines into one single security zone. So we have also multiple times said that this becomes like looks like a single blockchain, where people are transacting. The experience is much more seamless and all that. And the other important part is be capitalistic in nature. That means now you don't need to be on a shared blockchain. If you are a developer, whether you are a large enterprise or a crypto degen builder, or you are a college student who is building some game or some experimental application, you can simply spin up your kind of chain, or I call them sometimes these trustless servers and all that, and connect it, provide your ZK proofs into the aggregation layer. Your chain is as secure as any other chain in the ecosystem, right? So that's like having that same security zone across big, large, small applications. That's what like internet has provided today, whether it is a large scale website or web application, or there's a small application on the internet, they interact seamlessly together. Although there is the security, there is base security element, but this value security element is not there. With these blockchains, the security of the value element is also there. And I think it for me, it's like it looks very similar to the structure of the current internet, which is the trustful internet, and this architecture can provide the trustless internet feature. So that's why AggLayer for me. Hello, over to you.
Yeah, I can pretty much second what Sandeep said. First of all, I'm very excited about the whole aggregation thesis, as well as all of you guys and the rest of the team. I think in our firm belief, it's the next kind of evolutionary phase of blockchain design or blockchain infrastructure. And it's definitely going to take us a step closer to that end game, basically, which is a globally scalable, internet scale, basically, a network of value, which is seamlessly interconnected and feels like a single network, just like the internet, as Sandeep said. So, not to go into through the genesis kind of and retrospective of blockchain design and approaches that we have taken so far as the industry. So from monolithic to modular, we really believe again that aggregation aggregated blockchains are what is going to take the industry mainstream, basically. And the end game or the goal here is this, as I have been saying multiple times, this global network of value. So with the internet over the past couple of decades, we have, as the society, we have been able to establish this global network of information, which has, as we all know, transformed the society in very profound ways, right? And it kind of democratized access to information and knowledge, and made the entire society more efficient, more interconnected, and feels like this really network of equivalent network, but for value is really the missing part. It's almost like, how come that we still don't have this, right? And with the blockchains, specifically with aggregated blockchain approach and design direction, we really believe that we're really kind of seeing the clear path to actually build that global network of value, which will, in our firm belief, transform the society probably in even more profound ways than the internet has. So that is kind of the end game, and very excited about everything.
Yeah, I think that's a really nice way to put it. And I should note that in response to the chat, Sandeep is not a fugitive on the run. He's just on his way to ETH Denver, and is currently, I believe, outside the Eiffel Tower in Paris. So, Sandeep,
not for fun. Like, I am at NFT Paris, and I had a keynote here, and I'm freezing here, right?
Give us since we literally can't hear a word that you were saying, can we at least get a shot of the Eiffel Tower in the background?
Proof of location.
Okay, thank you.
Okay, so you couldn't hear anything?
I still can't hear you. Mark, over to you. So what we're announcing today is that the LXOY bridge contracts are live, and so this is like the very first step toward this aggregation layer vision. But there's also a really cool primitive that's being exposed with these contracts. It's called bridge and call, and it enables really cool cross-chain interactions across L2s in the Polygon ecosystem. Could you just describe? I believe we lost Mark. Could you just describe?
Take that one.
Just, Brendan, in the while, let me just point a comment because I think it's important for this. Just for this, I want to go back in 2015, the beginning of Ethereum, when there was not this division between data availability and execution layer. Was exactly the same, and we're talking about sharding, but sharding was like a kind of mix of roll up with data availability because it was everything together. Okay, and at that point, we already knew this thesis that that individual blockchain will not scale, and we will need many shards. We will need many execution environments or many shards by the time. And I remember the work done by the Ethereum Foundation by the time. I remember some Vitalik's talks talking about composability, talking about asynchronous calls between shards or between data availability. This aggregation layer actually is the evolution of that time. I mean, actually, we are building that part. Of course, here we have this distinction of data availability. We have the ZK. We have much more bigger advantages. For example, by the time the shards had to be very homogeneous at some point. Here with ZK, we can have we can give chains much more sovereign on each of the individual chains. But all the tech of this composability between chains of calls, and this refers to this this message and call. But we can even talk about further about this asynchronous calls or even atomic transactions. All this world of interconnecting chains. And this is the beginning of this era. Right now we start having different chains connected together, and actually is when this I think that today the historical part of today is that today it's possible that all that thing that was kind of theoretical today is it starts being possible, and all these interchain or layer 2 communication composability will start happen, and it's definitively possible. And here we have a huge space to grow and to build on that. If you want taking the simuls, if we have processors, one thing is doing a fast processor, which is a chain, and now it's going to have a multi-core processor. We have this idea of multi-core processors, and then of course the communication between processors and all that becomes a lot of important. So this is very much where we are from the technology perspective in the historical manner, in the historical point.
Yeah, I think that's a really good point. I think one way to look at this is we get all of the nice guarantees of sharding, where we have asynchronous and synchronous cross-chain transactions. We have low latency. We have really nice trust guarantees. But fundamentally, the requirements and restrictions of sharding are not imposed on chains. We can have a heterogeneous environment where chains can coordinate with shared sequencers or relays or builders, but we have this fundamental guarantee of safety and asset fungibility that's guaranteed by ZK. And so it's a permissionless environment rather than one that's very sort of centrally managed and monolithic. And I think that's a really powerful vision because it allows so many different participants to come together to build this ecosystem. And so I think it's really exciting. I think a lot of people are right to be skeptical of sharding, but I think this is a fundamentally different vision that preserves the same guarantees and has some really nice properties in terms of who the participants are, who's building it, and how it comes together. But Mark, before you were bridged to another stream involuntarily, we were talking about bridge and call. So if you could just go into
before Mark says something, can you hear me now? Not only I was sitting in open, it started raining. It started raining also. So that's the
Yeah.
first thing. And second thing is, Brandon, you said that you couldn't hear a word, and
Yeah.
Mihalo spoke after me, and he said,
Yeah.
"I
Yeah.
second what Steve said."
Yeah.
You're not
Yeah.
hearing me?
Yeah,
Because I can feel what you're saying.
Mihail's answer was very good. But Mark, so maybe you could go into like what bridge and call is, what behaviors and functionalities it exposes, and we can kind of go from there.
Yeah. Yeah. And I think it's worth kind of take a step back, right? And talk like this first component, like the LXLY bridge, this unified bridge, like what does it mean, right? And like for now, right, what it means is like relatively slow, relatively expensive, like transactions that still like hit kind of Ethereum, right? And that's like not what the AggLayer and its end vision is at all. But what we thought was there is actually a way that actually uses this unified bridge in a way that is going to create an amazing experience for like developers and users in terms of a unique feature. And this is where bridge and call comes into play, right? And so if you think of like your typical experience right now when you bridge onto an L2, you submit a transaction to actually bridge. Once you get and you've actually like bridged across, you then submit a transaction on whatever application that you want to use, and you use that application. And frankly, if you wanted to then leave that L2 and go to another one, you would bridge back to Ethereum and then bridge over and then start using an application again. What bridge and call allows you to do is in one transaction, bridge to an L2 that is connected to this unified bridge that is the first component of the AggLayer. And once you've done that in that same transaction, you could, let's use an example, you could take ETH that you just bridged and you could exchange it for Matic. In that exact same transaction, you could also take that Matic onto another chain and exchange that for a skin in a game and purchase a skin in a game. And so that is something that can all be done in one transaction with bridge and call that otherwise would probably take 4 or 5 separate transactions today. And that is all because of both this kind of unified bridge and the bridge and call function. And it kind of gives you just this little bit of insight into what the AggLayer might look like from a reduction of transactions perspective and cross-chain transactions. What it misses is that whole low latency feel and like one kind of unified experience, which is what's going to come in kind of the coming months.
Yeah, that makes sense. I think the way that I describe it often is like right now in a multi-chain ecosystem, you're sort of forced to choose between deploying your application or your NFT or your game on the same chain where there's liquidity, or trying to deploy it elsewhere and like actually bootstrap liquidity on that chain, trying to like bootstrap an NFT marketplace or an AMM or and that's actually really difficult to do, and it's something that I think is unnecessary for builders. And so like part of what makes this vision really powerful, in my opinion, is the fact that like an NFT, like you said, a game that's selling skins or an NFT collection or a DeFi primitive can deploy into the Polygon ecosystem and instantly access the liquidity that already exists and the shared state and the users that already exist in the ecosystem. And so like we're moving out of this mode where chains need to like play games and engage liquidity mining incentives to build liquidity on their chains. Like as a developer, you can directly focus on adding economic value in the form of a game or a DeFi primitive or an NFT collection. And you don't have to worry about bootstrapping liquidity. And so I think that this is like sort of a step change for the developer and the chain builder experience. And I think it's, you know, I'm very biased, but I think it's really exciting. And so
on one of the key things there, Brendan, right? Which is like the idea that like you as a developer actually get to focus on like what it is that you're here to do and what you're good at. And you can focus on like, how do I actually just create the best user experience possible not how do I have to worry about like attracting liquidity and attracting like all of these different pieces of infrastructure that you might need around that liquidity. You're now like, I'm just going to build, for example, the best game possible. And then I'm going to abstract as much away from that user as possible. And that's where I'm going to spend my time and energy. And that is much better for the developers who actually want to develop and don't need to worry about it. And it trickles down to the end users in a very meaningful way because they're going to end up getting a better experience as a result of that.
Yeah, exactly. And
Yeah.
I think the other half of this, and here, just give me 1 sec, Sandeep. I'm segueing it into a question for you and Milo. Like the other part of this is like chains aren't giving up anything to participate in this vision. Like there are no restrictions on how you do sequencing, on how like what your token is for staking or for gas or for governance. Like there's no revenue share that's imposed on chains, and so this is fundamentally like an open and permissionless vision that's not a rent-seeking one. And so I think like Milo and Sandeep, when you think about like building the value layer of the internet and what that looks like and why we aren't focused on restricting how chains behave in this ecosystem, like why do you think that that's powerful? What's sort of the benefit of that?
Sandeep, do you want to start?
So before we go,
and I think his internet access was cut off.
Yeah, Milo, to you.
Let me take it, and he will definitely rejoin. Yeah, so it's a very transformative approach. That approach of unified liquidity, first of all, is, I would say, transformative both for Web3 or DeFi, to be more specific, standards, and traditional finance standards. So we have a completely new primitive, something completely new. The opportunity to leverage other chains, other application, other projects liquidity, right? It's a completely kind of new concept. And as you said, currently in Web3 we have this multiple layer twos competing for finite basically amount of capital, having to employ different kind of incentives and whatnot to attract liquidity, and liquidity by default ends up being fragmented, right? Here we have a completely different paradigm where chains are working with each other instead of against each other. So it's a proper paradigm shift, right? And as I said, both for and for traditional finance. So it's really exciting to see how that will play out and how projects will leverage that, and you know what's going to come out of that. That being said, to answer your question, we have understood, first of all, as you know very well, and as a lot of work has been invested on the technical side of things, designing the AggLayer and the cryptography and how to make the whole thing efficient and scalable enough and all of that. But we have also, as you guys know, we have put a lot of thinking into how to really make this appealing or attractive to everyone to join. So we understood very early, I would say, also from that kind of business viewpoint, that this really has to be a public good. This really has to be a non-extractive service, non-extractive basically layer that is just going to bring benefits and bring value to all the chains that decide to participate, and not extract value, not limit sovereignty, not impose ideally any type of restrictions that you have to use this token or that token or whatever. You're completely free to do whatever you want to do in your ecosystem. There's just only this added benefit of shared liquidity, seamless interoperability with the entire ecosystem. So it's pretty exciting. And I would again say, of course, we are biased, but I think we have done a good work defining and designing the egg layer in a sense that it's really a public good and really a clear value add for every chain that decides to participate without extracting anything from them or limiting their sovereignty or anything like that. Yeah, over to you, Sam.
Absolutely, like the sovereignty. Brendan, can you hear me clearly? by the way. Yeah. So sovereignty basically has always been a very important element of that, and a testament to that is that you might have seen people who are active in the Polygon community that even layer ones, which are like near blockchain and then Canto and many other ecosystems like now which are completely separate. They're not even layer 2. They also want to join the AggLayer. And I really loved Vitalik's recent post regarding make Ethereum cypherpunk again. And in that one he mentioned that build tools, not empires, right? And I think like AggLayer is actually in its own inspiration is like that. Like we want to build a tool, a layer which everybody can use. It doesn't kind of restrict anybody, holds anybody. It just provides a great service and benefits. So if people want to use it on their own accord, they can use it. They are not like locked into anything or things like that. Like we don't want to do that. And then because it's a great service and there are so many advantages like interoperability and shared liquidity and all that, people would work over there. Another big advantage which I wanted to say, what Mark was also mentioning, bridge and call. Like many of the small features for the developers, let's say on ramping, right? In like how chains can work with each other. Like if one chain solves on ramping, then you can that on ramping solution, if they have a very kind of robust on ramping solution, that can be used by every other chain in the connected in the AggLayer, right? So you can just do a bridge and call on ramp and come there. One good chain solves withdrawal and deposits from an exchange, especially the withdrawals. All exchanges, all chains can get withdrawals integrated using bridge and call from an exchange and all that. So like as Mihalo was saying, that this is like one architecture which also allows all the chains to work with each other. Anybody solves one problem, whether it's for liquidity, exchange integrations, on ramping, and so many other things, everybody else gets benefited also with that.
And fortunately, we have one of the largest exchanges in the world that's launching a CDK chain in OKX. And so I think that vision is something that's like very immediate and accessible. Jordi, I apologize that we've not gotten to you as much, but maybe as one of the last questions, you could talk a little bit about why this vision is enabled with ZK. Like you alluded to it a little bit earlier in your talk, but maybe just like the magic of ZK and why that's what's enabling this technology to exist.
The full point at the end is the ZK gives this immediateness. I mean, you can prove something with a single proof, and you don't need any interaction. I mean, the ZK is this non-interactive part. I mean, you prove something, and that's there. You don't need to wait, and here you avoid all kind of gaming. I mean, of collaterals, gamings, going back and forth, and it gives you instant, or if you want, the time it takes to generate the proof, but which is every time, by the way, every time it's faster and faster. Okay, so this is what gives you the immediateness. Okay, and this, when we are talking about, we're talking about the shared liquidity, but this shared liquidity, when you have many chains, means that you need this immediateness. I mean, you go to one chain, you do execute something there, you go back, and this immediateness is what ZK can give you, because I mean, you prove, you are there. You prove, it's like a clock. You prove and you go, and this is the importance, the big importance of this tech. Actually, you could do that in, let's say, on chain, but would be not practical, because meaning that executing things in the consensus layer is with doing something in Solidity. You could build that, but consensus should execute so many pieces of code that makes it not practical. In ZK, you can compute that aside, you prove that aside, and in the consensus, you just give the proof, and the proof moves forward. And this is what enables everything. I mean, the big secret of this aggregation and because this is possible, is because this ZK.
That's awesome. So I think that's a good place to end this panel. Thanks to everyone, and yeah, let's over to Hudson.